In this video, I will guide you through creating a one-way ANOVA table manually, step by step, using the relevant formulas. In this first of a two-part series on one-way ANOVA hypothesis testing, we'll create the ANOVA table manually. Part 2 will focus on the hypothesis test itself, comparing group means at a chosen significance level. Let's consider the following case study, where a scientist is investigating the impact of different plant growth lamp types on seedling growth. Seedlings are assigned to groups and exposed to different lamp types. After a controlled growth period, the scientist measures the height of each seedling in centimeters. The study aims to determine if there's a statistically significant difference in seedling height due to the lamp types. The significance level is set at 0.05. Constructing a one-way ANOVA table manually involves several steps. First, we will calculate the sum of squares for each component. The total sum of squares represents the total variance in the data. Sum of squares between groups represents the variance between the groups. Sum of squares within groups represents the variance within the groups. Then, we will calculate the degrees of freedom for each component. The degrees of freedom between groups is k-1, where k is the number of groups. The degrees of freedom within groups is n-k, where n is the total sample size. The total degrees of freedom is n-1. In the next step, we will calculate the mean squares for each component, that is the mean squares between groups and the mean squares within groups, followed by computing the F statistic and the p-value. To calculate the sum of squares, we first need to determine the sample mean and variance for each group, as well as the overall or grand mean. These values can be calculated using the following formulas. Where in the ith group, xij is the jth observation, xi bar is the sample mean, nj is the number of observations, si square is the sample variance, and x double bar is the overall or grand mean. K is the number of groups being compared in the study. Capital N is the total number of observations across all the groups. For Group A, the sample mean is 15.3. The sample variance is 4.9. For Group B, the sample mean is 21.4. The sample variance is 4.93. For Group C, the sample mean is 9.7. The sample variance is 3.57. To calculate the grand mean, take the average of all the observations. The overall or grand mean is 15.467. Now, put the values of the sample size, the sample mean and the overall mean in the sum of squares between groups formula. The calculated sum of squares between groups is 684.867. And in the sum of squares within groups formula, put the values of the sample size and the sample variance. The calculated sum of squares within groups is 120.6. Add the sum of squares between groups and the sum of squares within groups to get the total sum of squares value. The calculated total sum of squares is 805.467. In the second step, we will calculate the degrees of freedom values. The degrees of freedom between groups is k-1, that is 3-1 equals 2, where k is the number of groups. The degrees of freedom within groups is n-k, that is 30-3 equals 27, where capital N is the total number of observations across all the groups. The total degrees of freedom is n-1, that is 30-1 equals 29. Now, we can estimate the variance between and within groups by calculating the mean squares from their respective sums of squares and degrees of freedom. By using the following formula. The mean squares between groups is 342.433, and the mean squares within groups is 4.467. The F statistic, a ratio of between group variance to within group variance, is calculated by dividing the mean squares between groups by the mean squares within groups. The F statistic is 76.664. This F statistic follows an F distribution with k-1 and n-k degrees of freedom, where k-1 is the between groups or nominator degrees of freedom and n-k is the within groups or denominator degrees of freedom. The F distribution table cannot directly be used to estimate the p-value. The F distribution table provides critical values, which you can compare the calculated F statistic to in order to estimate the p-value. Here's how to use an F distribution table to estimate the p-value. Considering the F distribution for the significance level of 0.05. First, locate the row in the table corresponding to the denominator degrees of freedom of 27. Then, find the column in that row corresponding to the numerator degrees of freedom of 2. The table value at this intersection represents the critical F value for a significance level of 0.05. The calculated F statistic of 76.664 is greater than the critical value of 3.3541. This means the p-value is less than the significance level of 0.05. The ANOVA table is obtained.